All right, so here we go. So this chapter starts doing these things, you guys, with these U substitutions, or yeah, it is a U substitution, where they give you this expression, U over the square root of U squared minus 1, and they ask you to make a substitution U equals secant theta, and show that the resulting expression is equal to cosecant. These are kind of like proofs, but not really. You just have to plug it in, whatever they tell you to plug in, and then just manipulate it using algebra to get the answer they want. So we can do this. So let's take secant and plug it in for those two u's. Okay, so I'll have secant theta over the square root of secant squared theta minus 1. Now, we just talked about the identities on the previous page, right? And there was an identity with a secant squared and a 1. So what is secant squared minus 1 equal to? Yeah, well, here's that identity. Tangent squared plus 1 equals secant squared. So if I take this identity and just move the 1 to the other side, tangent squared t is equal to secant squared minus 1. So just like we used to do with this one where we move stuff around, you can move stuff around with these as well. So when I move it around now, secant squared minus 1 is just equal to tangent squared. So secant squared minus 1 is just equal to tangent squared. Now, another way to do this would be to switch all of these to sines and cosines. You're going to get a complex fraction. You're going to simplify it. It's kind of ugly, though. This is a lot easier because what's the square root of tangent squared? Tangent. Gone. Gone. And now I have secant over tangent. Now I can switch to sines and cosines. 1 over cosine. Tangent is sine over cosine. Flip. And what do I get? Yep. 1 over sine, cosecant. And that's what they asked us to show. And then they did say assume that we're in quadrant 1 so that everything's positive. That wasn't too bad. All right, so now let's again use those new Pythagorean identities. So again, we're still kind of doing proofs this chapter, but it's now using the new identities as well. Whereas before we just used sine squared and cosine squared, now we're going to get to use these new ones. So how would we simplify this one? Thoughts on the numerator there? What do you guys want to do? What could we do with that numerator? Pull out a CSC. You've got a CSC in both GCF. So if I take it out, I'm left with 1 plus cotangent squared. Ooh, that sounds a little familiar. And then the bottom is secant squared minus tangent squared. All right, so let's look back at our identities. What's 1 plus cotangent squared? Oh, look, there it is. 1 plus cotangent squared is CSC squared. So this can replace with CSC squared. And the denominator, what's secant squared minus tangent squared? I don't know. Let's look. It is 1. Yeah, some of you already caught on. Look here. If I move stuff around again, what's secant squared minus tangent squared? Move this tangent to the other side. It's just equal to 1. So that gives me a 1. And so then I just multiply on the top. When you multiply, you add. And we are done. Cosecant cubed? Cool? I can give you a second.
So cool. Favorite thing we've done all year.
Yeah, 100%. Are you going to a field trip too? They're going to a field trip? You're going to a field trip? What time do you guys have to leave?
Whenever the bell rings.
You got 10 minutes.
When the bell rings.
When the bell rings. Give me a minute. Okay, this last part, you guys, is opposite angle identities. Okay? This is what we just did in the practice packet. So remember what we wrote. We wrote that sine, if sine of negative, we actually put the negative on the other side, but it's the same idea. So sine is equal to the opposite sign, right? Cosine, though, notice that there's no negative in here. So cosine stays the same. Sine, change sign. And tangent, change sign. Okay, so it's this negative in here. All right, that makes the difference. So all that this is going to mean is that, and I can draw this on a picture, right? We already kind of talked about it. So I'm not going to really go through the pictures. Let me show you what it means in terms of an actual problem. If they give you that the sine of t is negative 0.76, I don't know what t is, some angle, okay? But the sine of t is negative 0.76. What's the sine of the opposite of t? Well, what did it tell me? For sine, I have to change the signs. So if this is negative, what's the sign of the opposite of t going to be? Positive. For tangent, we do the same. That's all you have to. You don't have to write the plus, no. I was just emphasizing that it's positive. Yes. For tangent, they gave us a positive 3.2. So the tangent of negative x will be negative 3.2. For cosine, it doesn't change. So it's still going to be negative 0.29. Now the reason I emphasize this so much, you guys, is because you see the negative in here, and you automatically want to switch the sign. You want to say, oh, negative is a positive, and a positive is negative. You always want to switch. That's great. You can always switch, but only for sine and tangent. You cannot switch for cosine. Okay? So cosine started negative, cosine will end negative. Okay? So switch them for sine and tangent. Keep it the same for cosine. All right, this last one is just, you can figure this out. If the sine of u is 0.54, what's sine squared of negative u plus sine squared of, or plus cosine squared of it? Yeah, you don't even have to do that. This is equal to 1. It's sine squared plus cosine squared. Sine squared plus cosine squared is always 1. So, I mean, you could work it out, and I promise it would work. But anytime you see sine squared plus cosine squared, it's going to equal 1.
I'm just gonna copy.
Okay, field trip people, you may leave.
Bye.
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 I'll still be here, Mr. Davis. Don't worry.
Okay, good. We're going to talk here a little now. This was what the video was on last night. This is, you guys should have copied this page a little.
She explained it.
I'm going to explain it again. I might explain it a little differently, but it's still the same concept, okay?
The video
So-
wasn't working.
The video didn't work for you?
You had to like download the
Educreation. You guys not have that on your iPad?
It didn't tell me that.
Okay.
It took me a while. I just kind of clicked it and it was like,
Oh, really?
the video's not working.
All right. Well, I will. I'll re-explain.
Happy to know
Okay.
it's working.
All right. Ready?
Why don't you try to be good?
Bye, guys. Have a good time. I hope it's cold and rainy and boring.
Oh, I'm just kidding.
You're gonna have a great
Look at the beautiful geometric shape.
Where are you
Yes.
going?
Make sure you find math in everything you do.
Oh yeah.
Okay. Go.
Alright, kids.
Hey,
That's
you
true.
guys should, like, come to our table and get the whole table.
No, I think they're good. That's good.
Friendship.
Okay, ready? Let's talk about the periodicity. Okay, so basically what they talked about is that you have, this first part should have made sense. If you have some angle t, right, and I find its sine or its cosine, right, I get its coordinates, I can add revolutions to it, or I can subtract revolutions to it, but if it still ends up right on that same angle, it's going to have the same sine and the same cosine, so it's going to have the same coordinates, right? So like if I add a revolution to it, I'm still going to be right here. Well, how many radians are in a revolution? How many radians? 2 pi, 2 pi, 2 pi. So every time you add a revolution, you're adding 2 pi. That's what this means, right? So I'm adding 2 pi. I'm still going to be at the exact same coordinate. So I'm still going to have the same sign as the original one if I just added 2 pi. Make sense? Okay. What if I subtract 2 pi? I'm still going to be at the same, right? Depending on whichever way you go. You're still going to end up at that same point. So you're still going to have the same coordinates. You're still going to have the same sine, the same cosine. Okay. What if I added like 4 pi? That's the same. But 4 pi is just 2 more revolutions, right? So I can start with 1 here. Here's my t. And I can add 1 pi and then 2 pi. And I'm still going to have the same sine or the same cosine, right? Or I could add 6 pi, or I could add 8 pi, or I could add, right? What do you notice about all these things that I'm adding? They have to be multiples of 2 pi, right? How do I explain multiples of 2 pi? Well, we put in this little variable k. All that k is is k is an integer. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So what does that mean? If I had a 1 here, then I'd be adding 2k. If I had a 2 here, 2 times 2 pi would be 4 pi. So I'm adding 4 pi. And then I'm adding 6 pi. And then I'm adding 8 pi. All that this means, all that the k means, is that it's multiples of 2 pi. Okay? So we're just doing revolutions and revolutions and revolutions. Right? And you're still going to have the same answers for sine and cosine. So how does that help us to evaluate down here? All right? Now, my brain works a little differently, so I do these ones slightly differently. The way that the video had you explain it is very good. I think it makes complete sense. However, if you want another way to do them, I'm going to show you a slightly different way here. Okay? So what I would want us to do, 5 pi over 2. Okay? So for 5 pi over 2, what I'm going to try and do is rewrite that as some multiple of 2 pi plus a basic angle. Okay? So how could I rewrite 5 pi over 2 as a multiple of 2 pi? So how could I do like a 2 pi plus something else to equal 5 pi over 2? What would it be? You guys can do fractions. Come on. What would I have to add to 2 pi to get to 5 pi over 2? I'd have to add not 3 halves. I've already got this. What's the decimal here for 5 pi over 2? 2.5. I've already got 2. So I just need 1/2 more. Yeah? You guys agree?
Yeah.
That 2 halves plus pi over 2 would equal 5 pi over 2? Yeah? The 2 pi part is just going to disappear. I don't care about the 2 pi part. That's going to, because that's just an extra revolution. Okay? So I can get rid of the 2 pi part. So this is still just the sign of this. The 2 pi part is gone. And so now I'm just going to evaluate sine of pi over 2. And what is the sine of pi over 2? Well, that's 0, 1. So my sine is 1. So, again, all our brains work differently. The way that Miss Weber did it is a little different. She kind of works backwards, and that works great. I work the other direction. I try and build up to that versus going away. I don't know what the difference is. The other way you can think of this if you want to, and this is how some people do it, is they would rewrite it as like 4 pi over 2 plus pi over 2. Okay? 4 pi over 2 plus pi over 2, that's 5 pi over 2. Cool? 4 pi over 2 is just 2 pi. So that's gone. You're looking to find a multiple of 2 pi in there somehow. All right, let's try the next one, negative 17 pi. So what multiple of 2 pi could I use? 9 pi? That's not a multiple of 2. 18. You were going to 18? So he's thinking k would, I gotcha. So he would go with an 18, but we want to get to a negative. So negative 18? But how would I get to a negative 17 then? He's thinking. You could. Let's go, what about this? What if I did negative, and you could do 18 if you want, but I'm going to do this. Negative 16 minus pi. Does that get me to negative 17? Yeah. And how would the negative 16, well, negative 16 pi is just negative 2 pi times 8, right? That's just 8 revolutions. So this, since this is a multiple of 2 pi, right, it's a multiple of 2 pi, I can get rid of it. And so then all I have to evaluate is cosine of negative pi.
Wait, so you don't just cross out the 2 pi, you cross out anything that
Is a multiple of 2 pi. That's exactly right. So this was just a one multiple of 2 pi. That was an easy one. But a lot of the others are going to be times 2, times 3, times 4, times 8. Okay? So the multiple of 2 pi gets crossed out, and then you evaluate whatever is left over. So what's the cosine of negative pi? Yeah, it'd be negative 1. Good. Because negative pi would still be at pi. Okay, Solomon, go ahead.
Wait, so the answer for the first one was 1, right?
Yes.
You don't have to do your common one.
Yes.
Alright.
Because you're just finding the sign. They just asked us for the sign of it.
Alright.
So I looked at the ordered pair to get the y coordinate, which would be the sign. Okay. All right, 19 pi over 4. How could we split that up into, this is where our fractions come into play, something that's a multiple of 2 pi and something else. Now, they're usually keeping that same denominator of 4 is going to help. So I wanted to add to 19 on the top, but I need one that's a multiple of 2 pi and the other one that's my leftovers.
16 pi.
16 pi here? Let's try it. 16 pi, and then we'd have 3 pi left over, right? And 16 pi over 4, I like it because this becomes 4 pi, which is a multiple of 2 pi, so it's gone, and I just have to evaluate the sign of 3 pi over 4, which is root 2 over 2. Getting it a little bit?
Yeah, okay.
All right, let's try the next one. Negative 23 pi over 6. Again, keeping that same denominator of 6. Now, since it's negative, it's going to be helpful for these both to be negatives, just as sort of a hint there. So what two negative numbers would add up to give me negative 23?
12 pi.
So 12 and 11. Is 11 pi over 6 on our unit circle? Yeah, there you go. You're good. So that would work. Okay. You always want, this would be our 2 pi multiple. And then the leftover, you want to make sure it's on your unit circle. Okay? And if it is on your unit circle, you're good. If it's not, you got to go higher with this one. But trying to get higher, what could we do that would be higher? We could do negative, no we couldn't. Because we go to 24. Oh, you could do negative 24 plus pi over 6. That would work too. See that? Negative 24 pi plus 1 pi would give you negative 23. No? Yes? Too much? Too much? Okay. So this is my multiple of 2 pi, so it's gone. It is actually negative 2 pi, right? And then I would just evaluate the cosine of negative 11 pi over 6, which we know is root 3 over 2. Positive? Yeah, we're in quadrant 1, right? Okay, so again, there is other ways to do these. So if you went to the negative 24 pi plus pi over 6, it would also work. You get the exact same answer. Okay? Questions on those guys? All right, let's take a break. I'm going to make sure my video worked.